Hi again, on to the last module of dynamics now, which is linear momentum and its conservation. So the first thing that you will need to know in this one is the principle of conservation of momentum and how to solve problems using this principle. So the first thing is the principle, which is that in a closed system, right, because a closed system means no movement, no energy into or out of the system, right? So no energy is being introduced or leaving the system. So this becomes a closed system. Momentum is conserved across collisions, right? So what that means is the momentum, the total momentum of this, right, at this time is the same as the total momentum after these two particles collide and move apart from each other, is the same, right? So let's apply the principle of conservation of momentum to find the velocity of this particle, right? So the first thing is momentum before is equal to momentum after, right? So momentum before is 5 kg, right? There are two momentums, so just add them up. 5 kg times 3 meters per second plus 2 kg, right? Multiplied by negative 5 meters per second. Notice that it's a negative, right? Is equal to 5 kg, right? Because the formula is mv, right? That's why I'm multiplying these. 5 kg multiplied by negative 2 plus 2 kg multiplied by x, right? Where x is the velocity. Now, 5 into 3, 15. 2 into negative 5 is negative 10, right? Is equal to 5 into negative 2 is negative 10 plus 2x, right? So 2x is equal to 15, right? And this becomes x is equal to 7.5 meters per second. Notice that the sign is positive, right? So we know that the velocity that we have found is in the right direction. That is why the arrow is placed towards the right direction. So now we are done with this basic formulas, and the nuances will be dealt with in the next videos of past papers topicals, right? So next thing you need to know is elastic collisions, right? So what are elastic collisions? Basically, elastic collisions are occur when the kinetic energy, right? The sum of kinetic energy of all the objects that are colliding in a system is the same before and after the collisions, right? So even though the momentum was conserved, kinetic energy is not always conserved, right? Energy is lost due to some various factors like resistance, heat loss, or sound during collisions, right? So in elastic collisions, the kinetic energy is conserved across collisions, right? So they can even they can tell you that the collision is elastic and ask you to calculate the kinetic energy of a specific particle. And you should be able to do this using this principle. And the next and last thing you need to know about is that the relative speed of approach or separation is conserved across collisions. Now, what that means is a particle moving at 5 meters per second and a particle moving at 3 meters per second, right? So the relative speed of approach of these particles, as you can guess, is 8 meters per second. Because if you're on this particle, or if you're this particle, you will see this particle approaching you at a speed of 8 meters per second. A common example of this is driving on the wrong highway, right? If you are driving on the wrong highway and there are cars coming at you, you will experience them coming at you at a higher speed than they actually are, right? So, for example, if you're driving a car at 10 meters per second on a wrong highway, and one other car is coming at you with a speed of 20 meters per second, you will see them coming at you at a speed of 30 meters per second, right? This is a common example in real life that we experience every day. Now, what if the collision is basically elastic, right? Their velocity would be in such a way that when they separate, right? For example, this was 8, and the velocity of this object remains becomes 4 meters per second to the left. Now the velocity of this object would also be 4 meters per second to the right, right? And this is because the relative speed of separation here needs to be 8 meters per second if the collision is to be elastic, right? So this was 8 meters per second, and now the separation is also 8 meters per second. So these are the two things that you need to know about elastic collisions. Now we're done with dynamics, the syllabus of dynamics, and I'll see you in the topical videos. Do consider subscribing if this helped you out. And finally, thanks for watching. Goodbye.